Hey guys, I'm going to get started. So welcome to our session on Amazon Redshift. We're really excited to have the service announced. It's one we've been working on for quite some time inside AWS. My name's Anurag Gupta. I'm a director in the AWS Database Services team. And one of the teams that reports into me is responsible for Redshift. I imagine a lot of you were at, if not all of you, were at Andy's keynote yesterday, where he talked a little bit about Redshift. And we'll basically cover much of the same ground, but talk about it in a bit more detail, give you a little bit more insight into what we're trying to accomplish, why we believe there's a market for us in this space, and some of the things that we think we're doing that are different, better, differentiated, what have you. Okay? So let's get started. So I thought I'd start with a statement that should get a fair bit of head nodding in the room, which is that traditional databases, data warehousing in particular, is expensive and complicated. Hardware costs a lot, software costs a lot, even if they're both free. It's actually costs a lot to just tune and administer the thing. That's particularly true as you scale things out. And to a nonlinear degree. I mean, as you get from a 1 terabyte database to a 100 terabyte database, it's more than 100 times harder. So we personally feel that pain a lot within Amazon itself. You know, we're a notoriously data-driven company. We have a lot of data warehousing inside, and so we suffer from this as much as everybody else. And what we find is that when we talk to customers, they have the same experience. So large companies like ourselves get a lot of calls from vendors, and but these are typically high-margin vendors, and they're selling high-cost products. And so, like us, they have to ask themselves, what's the data that's worth analyzing? And like us, they're kind of uncomfortable with an answer that's somewhere south of 100%, right? Because how do you know years in advance whether something's going to be worth analyzing? And the second problem that they have is that the data is just hard to scale and so forth, right? If you're a small company, well, actually staying with large companies for a second, the other thing that people suffer from is that when you're buying software from a vendor that's charging a high price, it gets kind of chromed out in my terminology. People add a lot of functionalities to make it deserve that high price. And frankly, that just adds complexity. I don't know the last time that I looked forward to a database upgrade. It just feels like pain to me. Now, if you're a small company, the bright news spot is that no one's calling on you because you're not going to buy that software anyway. It's just too darn expensive. But that doesn't mean that you don't have analysis needs. And particularly in today's world, small companies are the ones generating big data. So I was talking to a small company that has a game coming out pretty soon, and they expect to generate a terabyte of data every single hour, more than 10 petabytes of data in a year. And they need to analyze that data. That's how they're going to monetize their game. It's a lot like other people in this room. And even more than a large company in many respects, the decision-making that's made on that data is incredibly important. It's about thriving and surviving. So what do? You can't afford a data warehouse, so instead, you build custom solutions. You run MapReduce jobs. And don't get me wrong, MapReduce is awesome. Love it. But there aren't that many people in any given company that can do that stuff well. And that itself acts as a constraint on what's analyzable. So pretty much since we started database services, our customers have been asking for data warehousing done the AWS way. So, Andy went through the slide, so I'll go through it quickly. So, what is that? It means it's easy to provision, it's easy to scale. It means you turn CapEx into OpEx. I don't know anybody who doesn't like things that are fast and cheap. And most importantly, people want us to respect their investments. I think one of the cool things about AWS is that we try to make things componentized, sort of in a service-oriented architecture, if you will. And we're taking that approach with the databases as well. So you can, if you've got investments in EMR jobs, digital transformations, if you've got investments in ETL tools, if you've got investments in BI tools or your custom analytical tools, we want to be able to support those. So when we set out on Redshift, we wanted to build something pretty significant, something that went from gigabytes of data to petabytes of data, something that would be at least 10x faster than the row stores that dominate data warehousing today, something that would be at least 10x cheaper than the column stores that have been emerging over the last decade, and something that would be a whole lot simpler than either, because both of the solutions that are out there right now, or categories of solutions that are out there right now, are really pretty complicated. And we really view that as much of a barrier to adoption and a barrier to analysis as anything else. And honestly, when I talked to some of my friends about what I was doing, they told me I was nuts. And they said, why do you want to get in a race with somebody who's got a 30-year head start, who's got 30 million lines of code already built, who's got 1,000 developers who are adding 1 man millennia of development onto that product every single year? And what it comes down to is that these products were designed 20 years ago, and the design point has changed because technology has changed. And it doesn't really matter so much that technology changes as long as things are changing at the same rate. And what creates opportunities for disruption and for new products is when the rates of change start to diverge. And we really believe that it doesn't matter if somebody's got a 30-year head start if they've been going in the wrong direction, right? And as I mentioned before, I've been seeing a lot of upgrades for a long time from database companies. I'm not too worried about what they're working on. So, I'm making some strong statements here. And so let's talk about how to back some of that up, right? So the first thing. So claim one, I guess, is that data warehousing performance is increasingly, or effectively almost entirely about I/O now. So 20 years ago, when I was working at another company on the data warehouse product, there was a different endpoint between memory and CPU and I/O. But the thing of it is that memory and CPU are on the semiconductor curve. They follow Moore's law. The performance and capacity double every 2 years. Hard disk drives follow a different kind of physics. First you need to move the disk head to the right track. Then you need to wait for the disk to spin around to the right sector. And so performance is getting better there too, but it's doubling every 10 years. And so what that means is that over the first 10 years in data warehousing, there's a factor of 16 in difference between where the original design point was. Over the next 10 years in data warehousing, that factor has grown to 256. Basically, data warehousing is an I/O problem. Amazon Redshift dramatically reduces I/O. So there's a bunch of stuff I'll go and touch on here, and it's a bunch of stuff that I'm sure a lot of you already know about, but just to get everybody in the room up to the same sort of speed. Most databases are what we call row major format. That means that the columns of an individual row are placed next to each other. And if you think about it, basically that kind of makes sense. You insert one row, you're probably doing one I/O. You read one row, you're probably doing one I/O, assuming it's not even cached. Now, you're not going to get any caching in the data warehouse because you're streaming a lot of data off of disk. And let's think about the case where you have 100 columns in your table and you're reading just 10. So then 90% of the data you're reading is useless to you. So instead, for a little while now, people have been working on column major databases where each block contains the data for just one column. And that way, I just read the columns that I care about for my query. And as long as there's a pretty significant ratio between the columns that I'm reading versus the columns that exist for a row, I get all of that benefit. Maybe you could think of that as maybe around 10x. The second thing that becomes interesting is that you can do a lot better data compression on the column-by-column basis. So for example, strings compress kind of differently from dates and numbers. Low cardinality data like states compress differently than high cardinality data like books somebody might be buying. Data that's sorted has some advantages about the kind of compression you might do versus data that's not sorted. So that's all about sort of reducing IOs. Secondly, we apply a bunch of advanced techniques around just not doing IOs at all where possible. So for example, we'll keep metadata around for each block to give us a sense of what might be inside it. And so if we know that what the data that we're looking for couldn't possibly be inside this block, we're just going to avoid reading it entirely. So third, we also try to just make the IOs that we do more efficient. So for example, Redshift uses direct attached storage directly on each compute node so that we don't have the overhead of bringing that data in across the network. We have much higher throughput and bandwidth for the data. And we also just try to make sure that we're using large block sizes. We place the blocks fairly sequentially on disks where possible. A lot of different techniques. This is just really a sample side, but basically we spend a lot of our time thinking about I/O. Secondly, the other big sort of thing that I think is transformative in the data warehousing industry is about the move towards scale-out architectures. And when I first started working in databases, the base problem was one of how to basically parcel out these scarce, expensive resources that were available in, let's say, a VAX cluster or something like that. The problem shifted. Hardware is next thing to free nowadays. The real problem nowadays is how to take advantage of the abundance of resources that you have. So let's take an example of what we do in Redshift. So if you have a query, we're basically going to come in through a JDBC ODBC interface to a leader node. It's responsible for doing the parsing and the query optimization, and it'll parcel out tasks to a bunch of compute nodes, which each have locally attached disks. They process their pieces, they do a lot of swizzling in between them, they send results back to the leader node. And so that scales out on commodity hardware with the number of compute nodes you have rather than having to do a forklift upgrade of a big single node box. So to this point, really, most of what I've been talking about is common with a lot of different columnar data warehouses. And I actually think that's a good thing because, a lot of us in the database business, the data warehousing business, are kind of conservative. We like kind of going down the main path, right? Anything that is stateful, you have to take a different level of care around. Where we start to add on to what other people have done thus far, in large part because of our heritage in managing services and feeling the pain that DBAs do otherwise, which maybe folks who are just sell you software licenses don't feel themselves, is to also take care of the other operations that are data parallel. So for example, load, backup, restore, resize, et cetera. I'll get into that in a little bit more detail later. So we've been running pilots in a private beta for about 6 months now. 20 different customers, give or take. I can't share the details of companies outside of Amazon, but let's just take a look at Amazon itself. So they've, as I mentioned before, we have some pretty big data warehouses inside, as you'd expect. So if you look at one of them on the current environment, it's 32 nodes. Each of those nodes has 4 CPUs. Each of those CPUs has 8 cores. And across the system, there's 4.2 terabytes of RAM and 1.6 petabytes of disk. So pretty beefy, right? So they took a bunch of tables out of that system, roughly about 2 billion rows, 6 representative queries so that they could kind of make sure that they were testing some boundary cases in our system where their existing system was running into some trouble. And they ran it on a 2-node Redshift cluster. Comes in at about $3.65 an hour on our 3-year RI pricing. Fair bit less than their current environment. So when I got the results back, I was kind of in a quandary because they're preposterously good. We actually toned it down for Andy's keynote because that was the one that was going to get quoted, so we just said 10x there. But in actuality, I'm just doing a subset of queries here. It was somewhere between 12x to maybe to 156x. Now that's just nuts, right? So let's talk a little bit about what's going on underneath that. So one part of that is, as I said, it doesn't matter how all of this other stuff that's going on in the system if your system is basically gated by I/O, right? And we're better at I/O, as I hope I've sort of talked about a little bit with you. And then the other thing is that we try to make sure that we use all of the bits that are available to us, all of the resources that are available to us. So when we get data in, we put it on every single spindle and on every single node. We make sure that when we run a query, we use every single core to run against every spindle and every node. And so that's kind of different from what other systems do. And it also makes a big difference. And then the third thing is, frankly, we've got one of the world's best DBA team in place, but at the end of the day, when you're operating at scale, you just can't optimize every single table and every single query. I'm sure if they'd taken, a couple of weeks or a month or whatever, they could have made these 6 queries scream on their current environment. Look at TPCH numbers from other people. I don't know anybody who gets TPCH numbers on their existing workloads. But people have invested a lot of time into that. And folks have asked me, why haven't we published TPCH's numbers? And the fact is we can't because it's a pre-production product. And I'm not really sure TPCH allows doing services. And the fact is, at some level, who cares? Because the product is cheap enough for you to be able to just try out for a couple of weeks against your own data for a couple $100 and just make sure that it works well on your data and your queries. Why use an artificial benchmark if you can actually compare your system against the system, right? So the other thing that I've been hearing a lot as I've sort of walked the floor around here was from people is that, okay, I saw that pricing, and I understand the whole Amazon disruptive pricing thing, but why that disruptive? You could have been twice as much, and you'd probably have been fine. And I have to say, I didn't hear that from any customers, just partners and analysts and folks like that. But let me just sort of explain what's going on underneath the scenes there. So the fact is, most data never makes its way into a data warehouse anymore for analysis. So let's say you started your data warehouse 10 years ago and you had all of your data in it. Well, if you're a typical enterprise, your data set is growing 50% a year. Let's say round numbers, it's doubling every 2 years. Data warehousing as an industry, the platform part of it, is growing at a little less than 10% a year. Again, round numbers, doubling every 10 years. So that means if you had all of your data in the data warehouse 10 years ago, on average, you've got 5% in it now. 10 years from now, you're going to have 1/4% in it. You cannot be a data-driven enterprise when you've got 1/4% of data inside your system. And I've had some people ask me around, on the floor, around here as well, like, okay, who are you trying to compete against for business and so forth? And the fact is, it's really nobody. Because our take is that if 95% of the data is on the floor, and we can go and capture that by providing better pricing and better product and something that's more manageable, and remove those constraints that let people analyze that data, I'm perfectly happy with that 95%. I don't need to worry about the remaining 5%. And like everything else in AWS, we let you start small and get big. So the underlying instance type for Redshift is hs1.8x large. It's a new instance type coming out from EC2. It's going to be made available to all of you, just like it's being made available to me. If you've got data-intensive workloads, that aren't appropriate for Redshift, it's worth checking out. So that's got 24 2-terabyte spindles on it, 120 gigs of RAM, 16 cores, and it's on a 10 gig E, minimally oversubscribed mesh network. So, decently beefy box. With that box, we actually only make 16 terabytes per node available to customers, and that's because we use the other space for mirroring data. We use it for being able to deal with disk failures. There's a bunch of other stuff there. But 16T of using Redshift of compressed data per node. And that lets us go from 32 terabytes up to 1.6 petabytes, which is good enough for launch, I think. And we also make that node type available split out 8 ways into an hs1.x large, which is basically 8 times smaller. So 3 spindles, 2 terabytes that are of space per, that we make available, 15 gigabytes of RAM, a couple of cores, again, the same 10 gig E network. And that takes you from basically 2 terabytes up to 64 terabytes. And with our pricing, we think that is actually economic down to the maybe hundreds of gigabytes range. So, oops, sorry, pressing the wrong button. So you guys saw the numbers yesterday on pricing, and our best estimate right now is that that's anywhere from 10 times to 25 times less than what you can get from your other database vendors out there right now. Really, that depends. You can't really pay attention to list prices in that case. So it's all a question of how much leverage you have versus your vendor has. Ours are transparent. These are the prices you get. What we've really focused on right now is to try to make pricing simple coming out for this product. So for example, we don't charge for the leader node. We don't charge for network transfer. We don't charge for backup up to the provision size of your cluster. So basically, for most people, what you're going to be doing is figuring out how many nodes do I want, of what type, how much data do I have, and just do some simple multiplication. So that's pretty nice. And we do expect that most people will start with on-demand, kick the tires for a while, and then eventually move to a reservation model just because, excuse me, data warehousing is a sticky business. So as I was saying earlier, it doesn't much matter if you do the first 2 things if you don't do the third. Because let's say your database was infinitely fast and was free. Well, even then, you've got this problem of, at scale, managing that database is still hard. And maybe not exponentially harder, but more than linearly harder as the sizes grow. So I've got a bunch of operations there that get harder. Gartner estimates that enterprises use 3 to 4 DBAs per data warehouse. That really depends on your size of data warehouse. I can tell you we use a fair bit more in some of ours. And that's also as much of a hard limit on what you can analyze, right? So Redshift does a lot of the same things as Amazon RDS in terms of simplifying manageability. So for example, you can create a cluster in minutes. We take care of OS and our own software patching, and we deal with scale ups and scale downs of number of nodes and the node types and size and all that. Now we've got a slightly different problem than RDS in that we're actually dealing with a ton of data. So let's talk a little bit about how we do scaling. So let's say you're going from a 10-node Redshift cluster to a 12-node Redshift cluster. So what we'll do is we'll spin up another 12-node cluster, dump in parallel from one, and load in parallel from the other. And the cool thing about that is while we put you into read-only mode for the duration of that, you can still run queries. Admittedly, the queries will run a little bit slower because the disks are doing some other traffic, but it's only going to be a little bit slower. And the other nice thing is that, like other things in Redshift, it's data parallel. So going from 3 nodes to 4 nodes should be around the same cost as going from 30 to 40. We've worked pretty hard on simplifying operations, so let's talk a little bit about security and auditing. If you give us a key for the system, we'll go and encrypt the data at rest and also when it's backed up. Your keys, not ours. And you want to do some sort of key rotation thing, give us a new key. You want to go and make sure that we don't keep the keys, use a key appliance, either on premise or in the cloud. And you decide that you don't want to use Redshift anymore, turn off your key appliance. All the data is garbage suddenly for us, right? Backup to S3, backups are actually a pretty interesting problem at scale. But backups to S3 are continuous, incremental, and automatic. So what we do whenever we go and add data to the system and create a new data block is that we're going to go and synchronously store it on some other node and some other disk within the cluster. And we're also going to asynchronously store it up into S3. And that means that 2 things. One thing it means is that if you lose a disk, we actually get pretty decent performance in being able to not actually have to rebuild that disk before, and we don't have any failures with respect to your queries. We're just going to end up doing an I/O, both a network I/O as well as the real I/O on another disk somewhere else in the cluster and pull it back in over the wire. Let's say you have a larger outage where both the primary and the secondary field inside the cluster go down. In that case, we're going to still keep things transparent from a query perspective, but we're going to pull in that data block from S3. And S3's got 11 nines durability. We don't really worry a lot about, they do, I don't, about losing data there. If you have a node failure, we'll provision a new node, bring the cluster back up, and at that point, it's basically a node with 24 disks that are failed, and it's running the same way. Actually, a lot of the failures that go on are more transitory rather than sort of like a disk failure where, like, for example, you momentarily lose power or you momentarily have a network blip. In those cases, we try to make sure that we actually get placed back onto the same node with the disk, with the data on top of it, rather than having to provision a new node, which is going to have to do this sort of restore. And so, let's say, okay, there's a bigger failure, some sort of a hurricane or a flood or what have you, and you need to end up in a different region or a different AZ. So, a lot of the tricks that I've talked about haven't worked. So there, we have a new feature called streaming restore, where we'll make the system come up as soon as we pull the metadata down. And then it's available for queries. And those queries are going to, we're populating the disks in parallel in the background, but we're also letting you run your queries, and the data blocks are going to fault in from S3 if we haven't yet gotten them local. And the reason we're doing that is that if you take a system like AWS Data Warehouse, well, it's got more than 3 years of data in it, but most of our queries are for the last day or the last week. And so that means that once you get less than 1% of the data back in, most of the queries are running just great again. And so we really view that as an interesting new innovation in the data warehousing industry. And it really speaks to our heritage in managing systems ourselves. I've had a lot of questions in the past few days about how we integrate, and as you'd expect, we talked a little bit about integration to S3 and how that's data parallel. We also have an integration to DynamoDB that's already done. We're working on an integration to EMR. We really believe that EMR is the next generation ETL for big data. It's how people are going to transform it at scale. And so what we're working on is basically going from every single node inside your HDFS cluster to every single node inside your Redshift cluster. So you get advantages of scale as your data sets grow, rather than having to come in through the front door. We talked about AWS data pipeline earlier today. So for systems that don't have that same kind of scale, like RDS or EC2 and so forth, you can certainly load through that path as well. And we've got any number of mechanisms to get data into the cloud from on-premise, and you're all aware of those, so I won't belabor those points. I've also had some questions about tools integrations. So one thing that we've done with Redshift is that it uses the same PostgreSQL drivers as Postgres itself. And so that means that if you're using a BI tool that integrates with Postgres, which is to say pretty much every BI tool, it probably works with Redshift. There may be some corner cases, but and we're in the midst of doing a bunch of certifications. We've already completed certifications with MicroStrategy and JasperSoft. They're actually in the database services booth there, and you can watch Redshift running underneath their products today live. And we've got a bunch of others in progress. And this is as important for being able to work against your own systems as tools, right? Because I can get a tool to work against, at scale. If I have enough customers, I can get them to work with me. That's very different than if you've got some tool that you've written yourself, and we all do, right? So with that, let me just shift to a last slide. So I was talking to a product management candidate a few weeks ago, and I asked him a question that I always ask most people I interview, which is like, okay, so if you were here in AWS, what would you do differently than what we're doing today? And so he had an answer which I really didn't expect, which was he'd raise prices. And his rationale, so I asked, I have to dig into that one. And so I asked him, why, what's going on? And he said, I just really don't understand you guys at the price that you're providing relative to the value that you're bringing to the table. And I especially don't understand when you've got a big set of customers already there perfectly happily paying your prices, why you'd possibly lower them so often. And so the problem is that he's thinking about things from a static perspective. And so I drew this little flywheel for him, which is actually linked. And so this is really the thought process that we think about with every AWS service, and which includes, of course, Redshift, which is we try to come to market with a low price. And what low prices give us is adoption. And the great thing about adoption from a price perspective is that it lets us scale our infrastructure. When you scale your infrastructure, there are more problems that are worth solving. If I have a $100 problem per customer, it's very much worth my while to put an engineer on it if I've got 10,000 customers, right? In a way that it's absolutely not worth anybody's while to do solve that same problem on premise. And if I solve that problem, it applies across my customers. I get increased efficiency. That lets me lower prices, and the flywheel turns, right? Similarly, he was right that there's a price-value argument, but we really try to come to market with what we consider to be the minimum viable product. The product that has just the set of features that we know everybody has to have, just to be able to do anything with the system. And so sometimes people look at what we've got and they say like, oh, it doesn't have the litany of features that I've got, and that's okay. Frankly, I've got my own list of 50 to 100 features that I'd love to be in Redshift, but I actually don't care that much what I think about those features. What's much more interesting is to be able, once I have adoption and get something out into the marketplace, I get feedback from customers, and that helps me prioritize the things that I add. And I've already had some surprises. There are things that I didn't expect to be important that were important. There are things that I thought would be important that people don't seem to care about that much. And by adding the features that matter most, I get to optimize my engineering resources. And that means that I get to optimize raising value. And again, that flywheel chain moves, right? Same thing, I get to gain adoption. So that's basically how we think about things. So when you look at the product today, it's fairly different from the product you're going to see a year from now. I don't know how it's different, but I know it's different. And so that's basically my last slide. I'd love to take some questions if you have any. I think we've got about 12 minutes. And after that, I'll go and hang out in the DB services booth. So if you've got anything, and just one more thing, which is that if you want, you can apply for the limited preview at awsamazon.com/redshift. We've actually got a bunch of people doing that right now. We're trying to roll out boxes right now, and this weekend we're putting some different bits on them than they had last week. So the first set of people will start coming on next week, and if you've got some more time, the full service launch will be in early 2013. Please. Absolutely. Yeah, so what happens there, so the question was, for folks who didn't hear, if you drop your data warehouse, since the data is backed up to S3, can I go and restore it again later on? And the answer is absolutely. The one thing that we do is that once you're no longer paying for your Redshift nodes, we are going to start charging you for your S3 storage. Right? But, please. Uh-huh.
How do you guarantee data integrity when you're running a query against a streaming score?
So what's going on, that's what I meant by the metadata that comes back. So the first thing that, if you think about it from the perspective of, let's say, Unix file system, if you got all of the inodes back, you don't need to necessarily get the data blocks themselves, right? Those can, come in as you need them. Or if you want to think about it in terms of like virtualized memory, if you knew the memory map, you can bring in the blocks off of disk whenever you need them. So it's a very similar sort of underpinning to things. Make sense? Okay.
I noticed you're talking about these clients that you support and the Asperson and all that stuff.
Uh-huh.
Is there any plan to make your own interface or client or
We don't really tend to talk about the future. It tends to change on us anyway. I think we're going to take that as customer feedback to us over time. At this point, I'm sure that we're just introducing a data warehousing service. People have a lot of investments in existing BI tools. So at some level, I kind of believe that represents a new layer of where things become portable, and so where you can maybe move around the tools underneath. I'd never say never by any stretch, and it's really going to be based on customer input to us. Sorry. Okay.
So you give sort of the results of your pilot testing.
Uh-huh.
It was 12 to 50 times faster.
Uh-huh.
Maybe I missed it faster than that.
Faster than the existing system that they're used today, where you saw the numbers that they were. I cannot. I don't think that. Yeah. So it's an interesting question. So we have a SQL interface. So it's to the degree that we want to talk about, multidimensional OLAP. We're really talking about a roll-up kind of model, much like, say, MicroStrategy uses on top of systems. Excuse me. So that, at the same time, we're not sort of restricted to star schemas. So you could just as well put an ODS operational data store schema underneath it. So for example, the AWS data warehouse is very much like just an arbitrary set of tables. I expect I'm going to add a couple myself for my own needs pretty soon. And so it's one of the things that we kind of designed for was not trying to optimize for particular schema types, because that also creates its own burden on people. So that's true for both the leader node and any compute nodes which have local disk on them. So sorry, the question was, if the leader node fails, do you have a failure? And yeah, if any node fails, basically what's going on is that we have to reprovision it. Now, so that's perhaps a multi-minute outage. Now, one of the things that is on my long list of 100 features I need to add that didn't make minimum viable product is the ability to let people provision an extra node as a hot standby to sort of come into that. Now, the question for me is going to be like, okay, what's the feedback? What's the utilization? How frequently is that multi-minute failure or sub-minute failure sufficiently important relative to other things I could be doing? Right?
So is this a way to arrange your vertical column stores or Hadoop? There was a paper by Stone Breaker where you compare vertical to Hadoop to show that it's comparable better. It looks like one of those.
It is very much down the lineage of Hadoop. I'm sorry, of Vertica and other columnar stores. I mean, obviously there were columnar stores that predate Vertica as well. We do believe very strongly inside AWS and inside database services that one size does not fit all. So, we've built DynamoDB for the people who want low latency, high throughput traffic. We think it's going to be a great source of event traffic into something like Redshift. We've got EMR, we've got support for RDS Oracle and SQL Server for people who need that functionality. We've got support for RDS MySQL for people who need low-cost transaction processing. So, we really believe that to solve different kinds of needs, you don't throw it all into one system because, frankly, that adds complexity. So RDS is a very different kind of system, right? So Redshift is data warehousing at scale, hundreds of gigabytes or petabyte or terabyte to petabyte, right? RDS gives you a management around existing commercial and open source databases. So it provides manageability, which is cool, but it also gives you systems that you're used to right now, and many of them are very good at transaction processing. I would not make any claim that Redshift is the right tool for transaction processing. It's not. Yeah, so so the question was, do we index things? And so one of the things that we've really tried to focus on is that in a columnar store, indexing actually ends up becoming much less important than a row-based store. And the maintenance headaches around indexing are, I think, less significant as well. To the degree that one wants to build the equivalent of an index, you can sort of do very much the same thing by building a secondary table that you look up in. It has its own issues. I'm not saying it's exactly equivalent. But that, for me, is part of the question about how to make things simpler, having fewer knobs that can be turned. Again, that's one of the things that we may end up considering depending on what customer workloads tell us. Thus far, we're doing pretty well without indexing. Zone maps are in their own way a form of indexing as well, of course. I really can't see in the back of the room from here, so sorry, go ahead. I'm sorry, could you say that again? It is absolutely ACID, and it's a database, so it's not like mostly a database or mostly SQL. It's a database. It's SQL. It's ACID. The data is partitioned based on a column that you specify as the hash partitioning key. We recommend very much that people try to co-locate their joins by making that key something that's relevant for so that you do local joins rather than traversing data across the network. It's one of the fundamental issues that actually ends up happening in Hadoop unless you're very careful about doing that kind of stuff yourself. We do allow you to do round-robin partitioning as well, but you lose some advantages there, although it's obviously in some ways simpler. So the question was, will we provide APIs to get the data out of the warehouse? Yes. Well, I think it's really hard to talk about real time and get all of your data out with respect to large-scale processing. So I really think of that as more of a problem of dealing with something that has to become data parallel across many nodes. So if you want all of your data out, it probably is something that you're going to use something that's sort of the inverse of the copy command for. If you want to just run a query to get some data out, well, obviously that's what we do all day, right?
Are there any statistical functions that are on top of this or anything?
Yeah, so there's a bunch of statistical functions and also window functions and stuff like that. I'm sure that list is going to grow over time. So for example, one of the things that isn't there right now that I've heard feedback from that I was surprised by is the importance of a data parallel median. Because for our customer base, being able to figure out TP50, TP99, it's a lot more important than it is for others. I just need to make sure that what I'm hearing from my first few customers is replicates as we go out to a broader base. Anything else? Oh, sorry, good. Uh-huh. Mm-hmm. I'm sorry, what was the last?
You're subject to the DynamoDB read capacity.
Yeah, at this moment, yes. In our first pass, we're very conscious of that issue, and we'll be looking at replacing. I'm sorry, the question was, when we're pulling data out of DynamoDB, are you subject to the read capacity limits? And so the answer is, right now, yes. There are things that we're trying to do inside DynamoDB to help with that problem.
Sorry, can you talk about the integration pattern for bringing data from Dynamo into Redshift directly so that they integrated stuff out of that?
Yeah, so actually, I'm not deep on that details of that. Maybe if we actually talk about that in the booth or afterwards, one or more of my colleagues might be able to help out a lot more. Sorry, go ahead.
How would you compare it with other in-memory columnar databases?
Sort of so the question was, how would you compare this to an in-memory columnar database? And in-memory columnar databases make a lot of sense. They really are at a different capacity point than what we're going after with Redshift. And very few people have the dollar resources to put a petabyte of data into memory. And maybe